All right, good morning everyone, or good afternoon. Hello everyone. We are going to get started here in just a second. Today we are going to be talking about friction and equilibrium. So what is equilibrium? Well, equilibrium is that situation where there are no unbalanced forces acting on an object. So if we're talking about net force and unbalanced forces, there are no unbalanced forces, so there's no net force. So do please write that. Equilibrium is where we have a situation where we have all forces balanced. Okay, so all our forces are balanced. So in this situation here, she is not moving the mower at this time. So right here in this moment, we have equilibrium. All the forces on this mower are balanced. So we do, however, have friction. Okay, so there's friction in those wheel bearings and friction between the wheels and the ground, and we're going to be talking about that as we go on today. Okay, so equilibrium, just know that that's where all forces are balanced. Okay, so today we're going to be talking about friction in more detail. We're going to be talking about coefficients of friction. By the end of this lesson, you'll be able to tell me what those are and hopefully be able to use those in problems. Okay. The other thing you have to be able to do, or should be able to do, is be able to explain the conditions for equilibrium and use those. Okay, so what is it that causes motion to stop here on Earth? So if I push my rolly chair, eventually it's going to stop. Why? Because of friction, right? We said that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an unbalanced force, an unchecked force. What is that unchecked force? It is friction. Okay, so friction, you can say, is the unbalanced force that acts on an object in motion. And there's four kinds. We have sliding friction, write that one down, rolling friction, fluid friction, and static friction. All right, so sliding friction, that's going to be like an ice skater. Rolling friction, anything that rolls, wheels, bowling balls. Fluid friction, that's going to be within air, which is a fluid, or within a liquid like syrup versus water. So syrup is going to have a lot more friction between the particles than something like water. And so when you try and pour syrup, it's a lot harder to pour. It pours much more slowly because of all that friction. So that's fluid friction. And then static friction is the initial friction when you try to get something to move. So say I'm pushing my rolly chair, or I'm pushing my phone on the counter here, on the desk here. I have to put in an initial amount of force to get it to start moving. Okay, so friction is an unbalanced force that acts on objects in motion, and we have four kinds: sliding, rolling, fluid, and static. Come on. All right, so we have experienced friction our whole lives. So if we were to take a book and slide it across a table, we know that eventually it's going to stop. We can't see it, but there's a force acting on it, and that force is friction. Okay, eventually it will stop due to friction. So that's, if there was no friction, inertia would continue to cause that book to move, and it would continue moving in that same direction at that same speed forever. And that's kind of what we see going on in space. Remember, we were talking about Sandra Bullock and gravity and how she started flying off in one direction, and had she done nothing about it, she would have continued flying off in that direction at that same speed forever. And so that's why our objects in space, like satellites and rockets, don't need a lot of fuel, because once they get going, there's no friction to resist movement. And so once they get going in the direction at the speed they want, they're just going to keep going at that same direction and speed forever. So friction forces, the nitty-gritty. So friction forces are forces that are parallel to the surfaces in contact. So if I have two surfaces in contact, friction is going to work parallel, either to the left or right. So if I'm moving to the right, it's going to work to the left. If I'm moving to the left, it's going to work to the right. Okay, so do please write that. Friction forces are parallel to the surfaces in contact and oppose motion or impending motion. So if it's not moving, it's going to resist impending motion. So if you're trying to get it to move, if you're pushing on it and it's not moving yet, that's impending motion. And friction forces are different for different surfaces because the microscopic surface of those surfaces, what they look like on the microscopic level, affects how hard they will resist motion. So the more surface area, which when we have something that's rough like that, we're going to have more surface area. The more surface area there is on that surface, like the desk or the floor or the ground, then the more friction there's going to be. There's going to be more surfaces to push against that motion, to resist that motion. So you know that different surfaces have different amounts of friction. So you're going to have a different amount of friction on asphalt versus the grass, which you know if you've ever played Mario Kart, right? You're going to have different surface friction when we're talking about a dry road versus a wet or an icy road, right? When it's wet or icy, you have a greatly reduced amount of friction, and so you slide all over the place. So friction forces are parallel to the surface, so they're parallel, not perpendicular, but parallel to the surfaces, and they resist motion. Okay, and we're going to be talking about two different kinds here in physics that resist motion. A static friction, where you have no motion, so an object that is at rest has static friction. That's the amount of force you have to put into it to get it to start moving. You have to kind of overcome that. And then we have kinetic friction. Now this may be a familiar word to you. So in middle school you learned about kinetic energy and potential energy. And potential energy was stored energy, and kinetic energy was the energy of motion. So when we're talking about kinetic friction, we're talking about the friction of an object that's already in motion. So you've already put in the amount of energy to get it to start, and now it's already in motion. And so that is always going to be, so the friction, the static up here is always going to be greater than the friction kinetic, the kinetic friction. Because once you've got it moving, it's actually easier to move. Okay, so I've got a bunch of stuff written here. So here, friction and the normal force. So let me just put all this here. The two things that I want you to, or really there are three things I want you to write on this slide. First of all, what the normal force is. We've talked about this, touched on this a little bit, but the normal force is perpendicular, okay, perpendicular to the surface of contact. So if we were to look at this surface here in each of these cases, the normal force is straight up, right? It's perpendicular to those contacts, the surface of contact there. And it's always, when we're talking about a flat surface, it's always equal and opposite to the weight. So remember we said Newton's third law was that for every action, there's a reaction. So for every force, there's an equal and opposite force acting on that. So our weight is pushing down with 4 newtons here on this one, but the normal force is pushing up with 4 newtons. The weight here with these two boxes is pushing down with 8 newtons, but the normal force is pushing up with 8 newtons, which is why the boxes aren't accelerating and the floor is not accelerating, or the surface there. And same deal here on this third one. Now, the force required to overcome static or kinetic friction in both cases is proportional to the normal force. What that means is the more normal force there is, okay, the heavier that object is, the more force you're going to have to use to push it. So the heavier it is, the more force you have to put in to get it to move and to continue it moving. Okay, so that's what these two equations down here, which I do want you to write down, represent. So this is talking about the static friction, right? How much you have to put in it to get it to start moving, versus kinetic friction, Remember, this one is always greater than that one. And that's how much energy, or rather, that's how much force you have to put in to continue it moving, to keep it moving. All right? So I think we're actually going to stop here, and I'm going to let you, we're going to do the problems next time. So again, friction is an opposing force. It opposes motion. And there's two kinds that we're talking about, static and kinetic. Static is when something's not moving, and kinetic is when something is moving. The normal force is equal and opposite to the weight if we're talking about a flat surface. And that's from Newton's third law. And that's all we're going to do for today. Let me know if you have any questions, and take care.